We'll start the topic for quantum mechanics. It is having some learning outputs, the history of quantum mechanics, and further of the quantum theory, basics of the quantum mechanics, the principle. Next one is particle wave duality, black body radiation application, history of quantum mechanics. We have come a long way in the journey of our understanding of the universe. We can understand our universe, still have the ages to cover. Historically, a quantum started with the Planck's publication of the black body radiation law in 1900. The beginning of the new development, the field of science, because we are in the early stages, we cannot know about from that quantum. After that, the level started with the Democritus, who was arguably the first person to state that matter is made up of extremely small, indistinguishable particles. Matter, atom. Atom is also tiny particles. Number of the atoms called molecules. After the Democritus, who is it argued that means it is for this matter is made up of extremely small, indistinguishable of the particles. Now we have called them atoms. Okay, this is first of all we called for matter. After we know about from that atoms. Theoretical predictions by several scientists over the past few decades and experimental to analysis how well these atoms or matter or tiny particles. We have got lot of the observation of the method way you can got it from that. Father of the quantum theory, Niels Bohr and Max Planck. This is two of the founding father of the quantum theory. Who is that? Niels Bohr and Max Planck. Each received the Nobel Prize in the physics for the work on quanta. Niels Bohr and Max Planck. Two of them got it from the quantum theory, including Einstein. Is the third founder of the quantum theory because it described light as a quanta. Light. We know from that light is traveling in the straight path. Is it? If any other interference comes, the light is also pending way is formed from that. That's all. But light has the natural of the dual quantity. That is dual purpose of that. One is for waves and another one is for the particles. The theory of the photoelectric effect, which have won the years of the Nobel Prize in 1921, Nobel Prize they got it from that Einstein. So totally, the father of the quantum theory means Niels Bohr, Max Planck, and Einstein. Here, this person is a Niels Bohr. And next one is this is Max Planck. This is Einstein. This is a very younger. It's okay. He was very young at the age of the times. Okay. Basics of the quantum mechanics. Why the quantum physics is needed? The classical mechanics. That is called for Newton's mechanics. And Maxwell's equations are called for electromagnetic theory can explain only for macroscopic phenomena. Macroscopic means it's a bigger level. For example, billiard balls and rackets, we have seen the outer side is a very huge one or large one. But quantum mechanics is based on explain microscopic phenomena or microscopic level, such as photon or atom. Photon means it's light. Is okay? And photon atoms scattering and flow of the electrons in semiconductor. That's why we have to got it from the quantum levels of the particles. And quantum mechanics is a collection of the postulates based on a huge number of the experimental and observations. What is the principle? When the quantum physics is applied to the not only for the macroscopic system, it is actually applied to the microscopic system, but it's really it is we have applied to the macroscopic system. It must reduce to that classical physics because the classical physics also macroscopic level we have reduced to get it from the quantum level. Therefore, the non-classical phenomena such as non-classical means there is an uncertainty of the principle. For example, you can take the blade Just you can accelerate the blade. You cannot predicate for that as the motion of the acceleration. Just you can wait for the stable state. Just start from the particle. After get it from the waves, so too much of the waves is got from that. It is a waves. That is why quantum mechanics deals with that waves and then particles. So must become undeductible. Niels Bohr is codified. This is for recommend for the correspondence of the principle. This is for 10 power minus 10 atoms and molecules of the, that is level, and 0.01 meter. This is for the level we have to calculating from that. This is quantum physics. This is classical physics. Some laws, physical models and predictions is used from that. Now come to the for direct point, particle, wave and duality. Particles and waves. Light it acts as the particles and waves. That's why we call for the duality. Waves is the particles. Max Planck work on the black body radiation. Because it is assumed that the molecules of the cavity walls describe the simple oscillator model. So we can exchange of the energy in the quantity of the units. And 1905, Einstein proposed for the energy in the electromagnetic field is not spread over a spherical wave. It is not a spherical, it is not formed to the spherical wave. It is also forming for the energy of the waves. That is why, so each quanta travels through the speed of the carrying of the discrete amount of the energy, that is called the momentum. And photon is used to explain the photoelectric effect. And particles for double slit experiment. What is means double slit experiment means Young's model is taking from that one of the light is passing through the one slit means it is only got from the particles way. If we have to add more than slit means the particles moving along with the slits they becomes for spread into the for waves. That is called for the double slit of the experiment. Already I took this topic for the black body radiation. In earlier days, centuries, the material is heated. It radiates heat and colors depends on the temperature. For example, the heating elements of the stove, if we heat means 550 degrees Celsius, dark red is formed, and 700 degrees Celsius, bright red is formed there. Then orange, yellow, and finally get from the white color. This is means the emission of the spectrum depends on the material. The theoretical description is simplifications used for the black body. So, Max Planck has got the Nobel Prize in 1918 for this black body of the radiation. His period is 1858 to 1947. What is black body? Material is constantly exchanging of the heat with its surroundings. It absorbs the radiation. The problem is it can reflect incoming of the radiations, which makes the theoretical description is a more difficult one. And black body is a perfect absorber. Incoming radiation is totally absorbed and none is reflected. Okay. Why had to study for the quantum mechanics? For used for the laser levels, we have used laser to get the particles and waves. Much more of the medical equipment used for the laser treatment. An electron microscope. We have seen the pixel. Any other pixels? Electron microscope means we have seen that at most a little bit of the tiny particles you can see that inner structure. And this is for MRI, magnetic resonance imaging. This device is a component used in computing of the hardware. Is used in for that medical. It is applied to the microscopic system, molecules, atoms, and subatomic of the molecules. Thank you.